water, getting 2 hydrogens and an oxygen. I'm going to record since some people aren't home, and then you can look at this later. It doesn't really record you, it just records what I'm doing, and I'll edit it up. Okay, so if you want that link, it's in Bless You. It's on the slide, ptable.com, and you can use that. Do this right. Okay, so we're going to look at, these are our equations from yesterday. You don't have to copy them down, you already have them. These are our choices when we're doing thermodynamics. And pretty much today we're only going to look at the first one. So if you remember correctly, our Q is our energy transfer. And that's what we're looking at. So the water goes into, the aluminum goes into the water tank, and it changes the temperature in the water. So it heats up the water a little bit. So we're going to look at the mass, the specific heat, and the temperature of both water and aluminum. So that's where we're going to go. Let's read the question together. So the question says, find the energy transferred when you put a block of aluminum at 80 degrees Celsius. So I have aluminum, it's 80 degrees. It's placed in 1 liter of water. We know that 1 liter of water is equal to 1 kilogram. And that water is 25 degrees Celsius. The water changes and gets warmer by 5 degrees Celsius. So that's all the stuff we have. And it says, find the energy transfer. So we're going to write down 2 things, what we have, what we're looking for. And then we'll pick our equations and solve. So I'm going to switch again. Forgive me for switching again. This is in Google Classroom under week 1. It says example in class. It looks like this. It doesn't have the work through. It just has the question. All right, so let me shrink that. Let me open up this. And then give me a light bulb. A little better. Okay, so we're going to work with this guy today. And I'll show you how to do that. You're not turning this in, but you can use it to understand your homework assignment. Goes up to you. I didn't take attendance yet, so don't leave. I totally forgot. I'll get on it, but let me start your question first. Okay, so looking at the question, let's write down all the things I have. I do this every single time I have a test. Yeah, it's overkill, but it keeps you from making mistakes, and it's the difference between the A and the B. If I'm on a timer, I do less. I scribble in what I have. If I'm not on a timer, I write it all out because I want that 99.999 so I don't lose any scholarship money in college. I don't have any issues getting into my next class. Okay, so what do I have? I know that aluminum is AL on the periodic table. The first letter is cap, second letter is lowercase. A lot of people get confused and say, well, why is it AI? Well, there's no element on the periodic table that's just A. So we're not worried about that. And A and I could not combine. So whenever you see this, you know it's AL aluminum, no matter how it's typed or written. So it's always aluminum. And that is 80 degrees. So I have this block. You don't have to draw the picture. It's aluminum. And it's hanging out in some sort of tank filled with water. So it just got dropped in there. The aluminum is 80 degrees. That's warm. I know that my initial temp of the water is 25 degrees. This is 25 degrees, and it's got water in it. It's a water tank. That says H2O. I'm just sloppy. I also know that my water is, there's 1 liter, and that's just equal to 1 kilogram. So that's the mass of the water. So we can say that's M of water. Or you can write the word mass. I know that the temperature of the water changes by 5 degrees because it said it in the question. So my final temp is of H2O is 30 degrees Celsius. I should make that one better. 1. We used to get points off in Catholic school if we wrote the number 1 with a line. It had to have like the top and the bottom. They take off -1 for every single one of those we messed up. Okay, what else do I know? I know the specific heat capacity of water. I don't really know that. It didn't say it in the question, but I need it. So I would look it up online and find out that water, or the specific heat capacity, C, of water, CW, is 4184. That's just something you would look up, or it would be given it to you. They usually give you a little table of knowns. And this one has that weird units. Joules divided by kilograms times degrees Celsius. So that's a little tricky. I also know that the water changes temp. So delta T for water, H2O, was 30, went to 25, and my total change, net change, is 5 degrees. So we're still doing what I have, just a lot of stuff. I want to do the same thing for aluminum. What's the specific heat capacity? And what's the change in temperature? So we're going to do it again. That's specific. I'm just being lazy there. That's capacity. I'm also being lazy there. And this time I'm going to do it for aluminum. Where am I? So, oh, I did not mean to do that. I meant to do aluminum. I went too fast. So aluminum, Al, we want the specific heat capacity, Al. And that's something I'd have to look up. And if you go on the periodic table and click aluminum, you'll see it on the left side at the bottom. It says 904. I'm just going to round it because we just want to figure out how to do this. We don't have to be so specific like electricity. I'm going to make it round, and I'm going to say it's 900. Joules per kilogram times delta C. And then one more thing I have to do is the change in temperature for aluminum. You can see that it was 80 when we started out, and it's going to drop by 30 degrees because the final temp down there is 30 degrees. So let's see what happens. So we're going to say change in temp for aluminum. So we'll subscript it. Starts out at 80. And the final temp of that water there is 30 degrees Celsius. So we're going to have a big old 50-degree change in the temperature. So that's a lot to wrap your head around. These things just come with doing them often. Repetition is key, and that's why teachers give you nonsense worksheets, because once you get familiar, you know what to look for. So we wrote down everything we have: the initial temps, the final temps. We have 2 materials, water and aluminum. We looked at specific heat for both, and we looked at temperature change for both. This is totally something I would write down on the side in my notes while I'm taking a test. Thank God I don't have to test on this anymore. Bless you, my allergy child. No, you're fine. It's hard to have allergies when there's COVID. I walk around coughing all morning. Oh my God, walking the dog. People are like, COVID, COVID, stay away. So most of that you took out of the question. Specific heat capacities you have to look up. Usually they're given to you. Because if you're taking a test or a final exam, the EOC, they know you need water specific heat. They know you need aluminum specific heat. So they usually supply it to you on a little chart. Also, 1 liter is equal to 1 kilogram of water, usually built into the question. So you just have to figure out, really, you only had to figure out the temperature changes. Water went from 30 to 25, and aluminum went from 80 to 30. So if you guys are okay with that, we'll move on to the next part, which is, what do I need? So I wrote down what I have. Now I got to write down, what do I need? What am I looking to solve out of that question? So I'm going to shrink this a little bit. Yep. Yeah. There's a bathroom pass built into Google Classroom. If you don't see it, oh, you don't have it yet. You have to use your phone and the QR code. Let me see if you have it. Oh, wait, I'm going to add you to the bathroom pass list. Hold on. Okay, so go in Google Classroom, look at the information board, and then Julian. Okay, update it. There's a form you have to sign in before and after, and you absolutely have to do it because they will rip us apart if it's not in there. Ms. Butler does not play. Okay, where's my question?
Did you know when our final exam is here or no?
What?
Females are for sure doing final exams this year.
I don't know anything about final exams this year, no. Not at all. I know for Project Lead the Way, if you want to get like credit at FAU to skip 2 classes, or if you want that Florida engineering certification, which you don't hear about until senior year, and then everybody wants it, and they come back and they're like, oh my God, can I increase my first year grade? No. So do that now. So you want to take this one even if you don't have to, and get a good score on it. This exam is hard. I struggled with it. We were writing it. I'm like, can you guys like not make it so hard?
The only thing I'm looking forward to is getting my ACE diploma so I can skip 2 years of college.
Yes. Did they let you skip 2 years for that?
Yeah, that's what the ACE diploma does. It allows you to only take 2 years of college.
Yeah, it's just you go to college.
Yeah, I don't think so. I don't think that's true. I think it depends on the college, maybe community college. I think it just helps you get into the college. I don't think you get to skip 2 years unless you do dual enroll. Andrew's asking if the ACE diploma lets you skip 2 years of college. Anybody know about that? Like the AA? I don't think so. I think it just gets you in there. Yeah. So the equivalent of the AA degree.
I know that it gives you total cost for free.
I know if you go to a big college, they're going to be like, hey, that's great. You're super smart. You did all this work. And now you got to do our work because our work is harder. So they're like, go you, but you're still doing everything. Okay. So the question says, calculate the energy transferred. So that's what I need. I need to find the energy transferred. So I'm going to write that down. What I have now, I'm going to write down what I need. I'm also going to need the mass of aluminum because that's going to be a problem. Anybody, do you mind getting that door? Okay. I don't want to run out of time. So I'm going to flip that page and I'm going to go to the next page. I am recording this so you could look at it later. But make sure you have specific heat for 2 materials and temperature for 2 materials. Yep.
Allows them to take college credit for all 4 years of being in high school, and you're not the level of flexibility that the other programs. But what are the benefits of starting an ACE diploma? earning an ACE diploma in conjunction with completing the required 100 hours of community service. Candidates will automatically earn a top Bright Future scholarship.
Oh, Bright Futures.
Otherwise, a Bright Futures scholarship is dependent upon the ACT scores, which are raised each year. Furthermore, when earned at the end of junior year, it helps set NFMHS ACE students apart from other candidates during college application process. I don't know what the 2 years
Okay, so let's write down what we need. We need Q, which is energy transferred. And we're going to need the mass of aluminum because it's in the equation. We'll look at the equation next. So it sounds like it gets you Bright Futures. Make sure you're copying this down, Jimmy. And it looks like you still have to do some classes. We wrote down what we need. So we always write two things. What do I have? What do I want? For any question. I have to remember to answer these questions. Okay, I got to get into how to solve it or we're never going to get through this today. So that's going to go away. We're going to look for the Q value, the energy transferred from the aluminum to the water. And we need the mass of aluminum to do it because it's in the equation. So that brings us to our next part. What equations do we need? So if you're still struggling there, 3 equations. What do we need? We're going to use Q. So that's mass times specific heat times change in temp. We're going to do that for both water and aluminum because there's 2 materials. We can also say that because they're in the same system, the aluminum's sitting in the puddle of water, that Q of aluminum, or the energy transferred of aluminum, has to equal the energy transferred to water. They have to equal each other. And that's just one of the laws that, says energy can't be destroyed. It's just moved from one place to another. So we can set those equal to each other. It's not one of those set equations. It's this equation. It's one time for aluminum, one time for water. You can open up the variables and see what you're missing. I love these things when you get them on a test because it's like, hey, all these numbers, all these variables, plug them in, see what's missing. It's like, okay, you can always get a good grade on these rather than explain why this person was thinking about something while sitting under a tree reading a book. I hate those. The first thing we're going to do is solve for Q of water, energy transferred of water. It's going away. It's going up. So the energy transferred for water, or the net heat transfer, because this is thermodynamics and we are transferring heat. So we can say the formula, the Q of water, H2O, is equal to the mass times the specific heat times the change in temp. The little dots are multiplication. And that is simply the equation we used yesterday. Q equals MC delta T. So now I'm just going to plug them in. We got the mass from the equation. It said 1 liter. That's a liquid weight. We need a solid weight, so we're going to call it 1 kilogram. It's an equivalent. So 1 kilogram is the mass. We had to look up specific heat capacity. They'd probably give it to us if we had a End of course exam question. You don't have to go crazy with these units. You can do the numbers. I like to do them so I don't screw up. And then we just figured out the change in temperature for water when we were on the first page. We said it was 30 and it became 25. I'm sorry, it was 25 and it became 30. So it was 25 when we started. Aluminum made it hotter, it became 30. So we had a 5-degree change. So we're going to put 5. So it really just is 1 times 4184 times 5. I'm totally going to round this answer, which I know I always tell you never to do. But we are not plugging in electricity, so we will not die. It's in joules because it's Q, and we gained this. The water gets the energy transfer, and that's something they won't tell you. You'll have to think it through. The water was sitting there minding its business. Aluminum popped in and said, hey, take my energy. So the water gains and the aluminum loses. And those are usually test questions. Who gained, who lost? Water gained, aluminum lost. Because the aluminum was hotter. The hotter one is the one that gives away because it goes hot to cold. So we're not done. We need to find the mass of the aluminum that popped in there. So we can see how much energy was transferred. So I got one more part to show you and then we're done. Sorry it's taking so long. So I'm going to move this up and I'm going to go to a new page. I'm going to leave that there if you didn't get it. If that'll hold. Okay. So the next thing we want to do, 5, is solve for the mass of aluminum, or MAL. That's mass of the aluminum block. So remember we had a little tank. It's filled with water. We dropped in this block on a string of aluminum. So aluminum, H2O. The aluminum was hot, so it was 80 degrees. And the water was cooler, it was 25 degrees. The aluminum is going to lose some of its energy, and the water is going to gain, and the temperature will rise because it gained the energy. So it makes the molecules move more, and that's what makes it warmer. That's why there's an energy change, because the molecules are not just sitting still, they're starting to move, and that gives it the heat. And we like that. Okay, so I am here. We know that the energy from aluminum gets lost. And we know that the energy of water, H2O, gets picked up from that loss, so it's gained. So aluminum says here, have my energy, and water says, okay, sounds like fun. So I'm going to just set those two equal to each other. So let's do energy of aluminum is equal to the mass of aluminum times the specific heat capacity times the change in temp for aluminum. So it looks like a lot, but it's really just 3 variables. So I have all of these variables, but I don't have the mass. So this right here is what I'm missing. I'm going to move this around, and I'm going to solve for that. I know, pain in the butt. Why do we have to do this? I don't know, because water temperature is important to the planet. So it might be worth the effort. We'll see. We could just do it one time and call it a day. All right, so I'm going to move this to solve for the mass of aluminum. I'm going to take the specific heat, or C, and the change in temp, or T. I'm going to take these two multiplications and put them on the other side. So I just divide them, and I end up with the mass of aluminum is equal to the energy transfer divided by those two, specific heat. And I'm writing AL next to everything so we know we're talking about it. Change in temp. And then you just plug it in. So we're going to use that specific heat that we found for water just a minute ago, 2100, because if the water's gaining it, which is what we just solved, so I'm going to go back for a second. We solved here that water gained 2100. It's equal to what aluminum lost. So it has to be the same number. You don't have to do the math again. And we're going to divide it by 900, which is specific heat capacity. I took it off the periodic table. And I'll multiply it by the change in temp. You guys love this class right now or hate it? We're only going to do one more of these. It's a homework question. And then we're going to build bridges. So if you're hating this, don't worry. It's going away. I didn't want you to go into the EOC and not have seen this. So you just do the math on that. And it's going to give you the mass of aluminum in kilograms. And that is what we're looking for. Ooh, sorry, the bell rang. But it's going to be 0.46 kilograms or 460. See if you can do it. Thank you for playing. Have a good day. I'll put this video in Google Classroom. Take attendance from my recording.
Miss